All right, welcome back. I am all chaied up. I got this chai, actually it's from India. That's the black Assam tea with a bunch of different like whole spices in it. It's awesome. Okay, so now, oh, remind me, I should bring in tea. I gotta bring in tea one morning for class. Keep on me about it. We'll do it. All right, let's do some more complicated examples with implicit equations. All right, so for example, let's do, we want to find the derivative of x squared y cubed is equal to 8 plus y. Okay, and I want to find dy dx. All right, so here, step one is always we're going to take d dx of both sides. So d dx of both sides. And I'm going to distribute for sums and differences, never for products and quotients. So therefore, for this first term, I can't distribute the derivative because I've got a product actually, x squared y cubed. And then on the right-hand side, I've got the derivative of 8, and I do have a sum, so I can distribute the derivative, and the derivative of y. Okay, let's deal with the right-hand side first because that's a lot easier. So the derivative of a constant 0, easy. And then the derivative of y with respect to x is, so the derivative of y is just 1. But then don't forget you have to multiply it by the chain, which is dy dx. Okay, now the left-hand side is a little more challenging because I've got a product here. So I've got a product of x squared times y cubed. So I've got a u times a v. So I'm just going to use the product rule like I did before. So, so u is equal to x squared, and u prime is going to be, now here you have to be careful here. So here, x and x, so same. So even though the chain's there, it's 1. So the derivative of x squared is going to be 2x times x prime, which is 1, so we don't write it. Now v is equal to y cubed. And here's where I have to be careful because differentiating y cubed with respect to x, so different, have to include the chain. So y prime then is going to be the derivative of y cubed with respect to x, which is 3 times y squared, times the chain, which is dy dx. So the whole left-hand side here is going to be the product rule, which is u prime v plus u v prime, and that's equal to the right-hand side, which in this case was dy dx. Okay, so I'm going to put in my values here. So u prime is 2x times v, which is y cubed, plus u, which is x squared, times v prime, which is 3y squared times dy dx. And that's all equal to dy dx. Okay, so let's see, what was step 2 again? Okay, step 2 from before is to, so step 1 is take dx of both sides. And then step 2 is really to isolate or solve for dy dx. Okay, so what you want to do is here, I'm going to multiply out up here. So I've got 2x times y cubed. So I'm going to write that as 2x y cubed. And then I've got plus x squared times 3y squared dy dx. So I'm going to write that as plus 3x squared y squared times dy dx. And that's equal to dy dx. And remember, what you want to do at this point is get everything that's touching a dy dx on the left-hand side and everything else on the right-hand side. So everything that's touching a dy dx, I'm going to get on the left-hand side. And everything that's not touching a dy dx, I'm going to get on the right-hand side. So what I'm going to have to do is I'm going to have to subtract both sides by dy dx, and I'm going to have to subtract both sides by 2x y cubed. And so if I do so, then I'm going to get 3x squared y squared dy dx, and then I'm going to subtract this term from both sides, so that's minus dy dx. And that's equal to, I'm going to subtract this term, so that's minus 2xy cubed. And then the last thing I need to do is I need to factor out a dy dx. So I'm going to factor out the dy dx on the left-hand side, which leaves me with 3x squared y squared minus 1, and that's equal to minus 2xy cubed. So dy dx then, if I divide both sides by what's touching the dy dx, I get minus 2xy cubed all over 3x squared y squared minus 1. Done. I strongly encourage you to go through these and make sure you can repeat them before you attempt the homework. All right, let's do another one. Okay, so new page. All right, cool. Let's do another one. It's a little tricky. So, for example, let's say I have the square root of x times y plus 7 is equal to x to the 5th plus y squared. And I want to find dy dx. Okay, so what I'm going to do here is I'm going to, step 1 is to take d dx of both sides. And again, I'm going to distribute for, excuse me, let me get some of this chai. All right, so, yeah, I've got my chai going in the hydro flask. Not the big tree trunk one, as Carolyn put it the other day, but one of the smaller ones. Okay, so now I want to distribute d dx throughout the entire thing, but only for, I'm only going to distribute for sums and differences, never for products or quotients. Now, one of the things that I want to do, and actually I should probably do this before I even distribute, is if you have something like this where I'm going to have to use a chain rule, I'm going to rewrite the equation first. So I've got xy to the 1/2 plus 7 is equal to x to the 5th plus y squared. Okay, so now I'm going to take d dx of both sides. So I've got d dx of xy to the 1/2 power plus d dx of 7, and that's equal to d dx of x to the 5th plus d dx of y squared. Okay, as you can kind of see, the one that's difficult is the first term, so let's do the others. So here the derivative of 7 is 0. And then the derivative of x to the 5th is just 5x to the 4th. And then the derivative of y squared with respect to x is going to be 2y times the chain, which is dy dx. All right, now over here, I've got some trickery because I've got to use the chain rule because I've got something to the 1/2 power. And so something to the 1/2 power, the derivative of something to the 1/2 power is going to be 1/2 of that something to the negative 1/2 times the derivative of that thing. So it's 1/2 of that something, and the something is what's inside, which is x times y. So I've got 1/2 of x times y to the negative 1/2 power times the derivative of what's inside. So it's the derivative of x times y. And so the derivative of x times y, I'm going to have to use a product rule here because I'm going to need to take the derivative of x times y. So here, let's see if we can do this in our head. So I've got a product rule with x times y, and I'm taking the derivative. So it's the derivative of the first, so derivative of x is just 1, times y, plus the first, which is x, times the derivative of the second. And the second is y, so the derivative of y is 1, but times the chain dy dx. So this is going to get a little bit messy here. So I'm going to, and this is equal to what's above. So I'm going to rewrite this whole thing. So I've got, so let's be careful here. So I've got, I'm going to write this as 1 over 2 square root of xy times y plus x dy dx. And that's equal to 5x to the 4th plus 2y dy dx. Okay, now this gets even more complicated, unfortunately. I hope you guys love algebra, because here I've got to distribute this term so that I can get this dy dx by itself. So I'm going to go ahead and multiply this out. So I've got, so I'm going to FOIL that. Well, not really foiling, I'm sorry, just distributing it. So I've got y over 2 square root of xy plus x over 2 square root of xy times dy dx is equal to 5x to the fourth plus 2y times dy dx. Okay, so so now you can kind of see why I needed to distribute that, so I can isolate my dy dx's. But before I do so, I can simplify here. So this term here, I've got y over the square root of y. So I've got y over y to the 1/2. So I can write this term here as the square root of, actually I can write it as the square root of y over x, 1 over 2. And then here, x over square root of x is, so it's going to be plus 1/2 of the square root of x over y times dy dx. Okay, I don't want to kind of eliminate this, so I'm going to erase the top here. And I'm going to continue this up at the top. Now these are, these, unfortunately, there's just a lot of algebra you got to pay attention to. So I'm going to rewrite this. So I've got 1/2 times the square root of y over x plus 1/2 times the square root of x over y times dy dx. And that's equal to 5x to the fourth plus 2y times dy dx. Now, one of the things is I really kind of dislike having fractions in these, and which you can, and actually on the AP test as well, you want to get the answer as a single quotient. And so what I'm going to do is I'm going to multiply through by the common denominator. And so here the common denominator, and it's really on this side here, is 2 square root of x times the square root of y. So I'm going to multiply the whole equation by 2 times the square root of x square root of y. And so if I do so, then this first term becomes the 2's cancel, the square roots of x cancels, and the square root of y times the square root of y is just y. So this becomes y. And then the second term, if I multiply it by 2 square root of x times the square root of y, the 2 and the square root of y's cancel, and I get square root of x times the square root of x, which is just x. So you can see right away this is starting to look a little bit nicer. And then on this side, it's not going to look as pretty, but at least it will work. So I've got 5x to the fourth times 2 square root of x square root of y. So this is going to be 10 times x to the fourth times the square root of x square root of y plus 4 times y times square root of y square root of x dy dx. Alright, so here x to the fourth times x to the 1/2 is going to be x to the fourth plus 1/2. So 4 plus 1/2 is going to be 8/2, so it's going to be x to the 9/2. And y times y to the 1/2 is 1, so that's y to the 3/2. So I've got y plus x dy dx is equal to 10 times x to the 9/2 times the square root of y plus 4 times y to the 3/2 square root of x dy dx. Alright, next we want to solve for dy dx. So everything that's touching a dy dx we want to get on the left hand side and everything else on the right hand side. So I'm going to erase so we can continue. And unfortunately these are like just they're just messy, but they're pretty fun. Alright, alright, so I'm going to get everything with the dy dx over the left hand side, everything else to the right hand side. So I've got x dy dx minus 4 times y to the 3/2 square root of x dy dx is equal to 10x to the 9/2 times the square root of y minus y. All right, next I'm going to see what I can factor. So I can factor out a dy dx here. I could factor out a square root of x. I'm not going to, just because I don't want to make it more confusing than it is. And on the other side, I could factor out a square root of y, but I'm just going to leave it. So I'm going to factor out this dy dx, and if I do so, I factor this dy dx out. So I'm just left with the x minus 4y to 3 halves square root of x. So then I get dy dx is equal to 10x to the 9 halves square root of y minus y all over x minus 4 y to 3 halves, 3 halves square root of x. Done. Messy, but that's how you do it. All right, we'll come back and do 2 more examples, and then there's a final thing we need to cover. All right, see you soon.